Hello everyone and welcome back. Today we are starting a comprehensive guide on vector algebra. Think about your daily life. If someone asks for your height, you say 1.6 meters, for example. That's just a single number, a magnitude. We call these quantities scalars like mass, time, temperature, and work. But now, imagine a football player passing a ball. They need to use a certain amount of strength. That's the magnitude, but they also have to aim in a certain direction. This is a vector quantity. In mathematics and physics, a vector is represented geometrically as a directed line segment written as AB. It starts at an initial point A and ends at a terminal point B. The length of this segment is its magnitude, denoted by these absolute value bars, mod of A or magnitude of A. Because length is never negative, magnitude is always greater than or equal to 0. Now, let's ground this in a 3D coordinate system. If you have a point P in space with coordinates x, y, z, its vector relative to the origin 0, 0, 0 is called its position vector OP. By applying the distance formula, the magnitude of this vector is simply r equals square root of x square plus y square plus z square. Next up, how do we track a vector's direction in 3D space? We look at the angles it forms with the positive x, y and z axes. We call these direction angles as alpha, beta and gamma. Take the cosine of these angles and you will get the direction cosines, usually written as L, M and N. An incredible identity to remember that the sum of the squares of your direction cosines always equals 1. L square plus M square plus N square equals 1. If we multiply these cosines by the total magnitude R, we get numbers proportional to them, which we call direction ratios, denoted by A, B, C. Before we jump into calculations, let's quickly classify the types of vectors we will encounter. First is the zero vector. This happens when the starting and ending points are exactly the same, meaning it has zero magnitude and no fixed direction. Second is the unit vector, which is extremely crucial. Its magnitude is exactly 1 unit and we denote it with a cap symbol, A cap. So if you want to find the unit vector, simply divide any vector by its own magnitude, you will get the unit vector. Co-initial vectors are simply that launch from the exact same starting point. Collinear vectors are vectors to the very same straight line. Their lengths or facing the directions doesn't matter as long as they run parallel. They are collinear. Equal vectors must satisfy two strict conditions. They must both have the exact same magnitude and the exact same direction, no matter where they sit in space. Lastly, the negative of a vector keeps the same length but flips 180 degrees in direction, meaning vector BA is the negative of vector AB. Let's talk about moving vectors around. if a person walks from point A to point B and then from point B to point C, their total net displacement is from A to C. So the next topic will be based on this, that is the vector addition and component form. So we can add by using triangle law and parallelogram law, and we will see one more component form. So the triangle law of vector addition, AB plus BC equals AC. An interesting takeaway here is that if you take the sides of a triangle in a continuous cyclic order, the resultant sum drops to 0 because your starting and ending points completely overlap. Alternatively, if two vectors originate from the same point, we can use the parallelogram law, where the diagonal passing through their common origin represents their sum. So you can see from the diagram, the vector A is there, vector B is there, and through the diagonal, the sum of the two vectors A plus B. To make addition algebraically easy, we break vectors down to their component form. We assign the unit vectors I cap, j cap, and k cap to track the basic step along the x, y, and z axis respectively, right? So any spatial vector can be written smoothly as x I cap plus y j cap and z k cap. Here the coefficients x, y, and z are called the scalar components, while the terms with the unit vectors are the vector components. So x, y, z is the scalar component, and the vector component is x I cap, y j cap, z k cap. And the magnitude can be calculated using the distance formula, mod of r, or magnitude of r is under root x square plus y square plus z square. So that is the component form. Finally, let's explore how we multiply two vectors together. Unlike normal numbers, vectors can be multiplied in two completely different ways depending on what output you need. The first is the scalar product or dot product, written as A dot B. The formula is magnitude of A multiplied by magnitude of B multiplied by cos theta, and it outputs a pure scalar number. So a crucial rule to remember is, if the dot product of two non-zero vectors is exactly 0, it means that they are perpendicular to each other because cos 90 degrees is 0. Geometrically, we use the dot product to find the projection of one vector along another. The second way is the vector product or cross product, written as A cross B. Its formula is magnitude of A multiplied by magnitude of B multiplied by sine theta in the direction of n cap. So we have to multiply that also, where n cap is a unit vector pointing perpendicular to the plane containing both the vectors, dictated by the right hand rule. If a cross product yields a zero vector, it tells you that the two vectors are parallel. And also keep in mind that the cross product is non-communicative. Flipping the order introduces a negative sign. We can use the magnitude of the cross product to instantly find the area of a triangle, or area of parallelogram formed by two adjacent vector sides. So area of triangle is half magnitude of cross product of the two vectors. And similarly, area of parallelogram is magnitude of A cross B. So make sure you practice calculating the cross product using its determinant form, and you will easily clear any vector problem coming your way. Thanks for watching. Like, share and subscribe. Comment if you have any doubts. See you in the next video.